17, it says, which quadratic equation defines the function that has zeros at -7 and 3? What does zeros mean?
Like, solutions.
Solutions, or where it crosses the x-axis, because that's what solutions are. So if that part of the vocabulary was giving you trouble, you need to make sure you realize zeros mean x-intercepts, or where it crosses the x-axis, or solutions. So several ways you could go about this problem. When I was doing this problem in my head real fast, as you know, because I wasn't reading them apparently as I was going through, I factored it quickly because that is the fastest thing for me. So when I factored it in my head, I knew that it was going to have to be x plus 7 times x minus 3 factored to give me those two answers. So the only one that factors to be x plus 7 times x minus 3 is C. But the other way you could do it is how? Type it into Desmos and see which one of these cross at -7 and 3. Does that take a little bit longer? Yes, but it gives you the right answer. Yes. We're not to number 19 yet. Do you have a question about 17?
No.
Okay. Ruby. You get Desmos on part of SC Ready and part not. So SC Ready is going to have two parts, a calculator part and a no calculator part. On the calculator part, you get Desmos. It's already built into the test. On the no calculator part, you get nothing. So there'll be some things like estimating square roots, estimating cube roots on there. So we got to review that between now. Well, you should have looked at it last year in honors, but make sure that you reviewed it before we take SC Ready. Any questions about 17? Yes.
Are you going to say, do we get Desmos for the whole thing?
Yes. All right, now let's look at 18. So 18 says, which quadratic has zeros at -1/2 and 5/3? There is definitely a faster way than using Desmos here. Does anybody know what that faster way might be? Morgan? It's already factored, and so we would just set each piece equal to 0. So if you set each piece equal to 0, A is the one that gives you -1/2 and positive, oh, you can't see that. -1/2 and positive 5/3. Do I need to work that out to show you guys? Because I can't. So you would say 2x plus 1 equals 0 and 3x minus 5 equals 0 and solve. But you could also use Desmos. If you typed it into Desmos, what would you be looking for? Where it crosses the x-axis. So if you forget about the zero product property, it's actually faster than using Desmos here. You could still use Desmos. So that doesn't go away. Questions on 18? When we get to 19, I'll give you the new instructions that go along with it, and then I will help you. But I've got to get people through the one I've already asked them to do. All right. Now we're looking at 19, and there's something missing from the instructions. It does say simplify. And on the common assessment, it's going to just say simplify, but there will be answer choices there, multiple choice for you to see. So you'll know kind of which direction it wants you to go. Because there are two ways you can simplify this problem right now. You can simplify it and leave square roots in the answer, or you can simplify it and leave just exponents in the answer. In the answer choices that it gives you on there, it wants just exponents. But I'm going to show you both ways here because on EOC, I don't know which way it would go. So if we're just using exponents, can somebody tell me what a square root is as an exponent? I can't hear you. 1/2. The 2 is in the denominator. Remember yesterday we said the square root is the same thing as a 1/2 exponent. The cube root is the same thing as a 1/3 exponent. So couldn't I rewrite this as x to the 3rd, y squared over z to the 5th, all to the 1/2 power? Would that be the same thing?
Hold on a minute. I need to write all this down. I'm very slow already.
So that would be the same thing, but when you look at your answer choices, that's not going to be one of the answer choices. Ashley, I haven't written anything else down. I am waiting. I'm not writing anything else down until you finish. I'm not going to leave you, I promise. So none of the answer choices are going to look like this. So we've got to do something else. We learned if you raise a power to a power, do you add, subtract, or multiply the powers? you multiply. If you raise a power to a power, you multiply. So if I raise 3 to the 1/2 power, what is 3 times 1/2? 3/2. So I could rewrite this as x to the 3/2 power. What is 2 times 1/2? 1. Now you might be saying, Miss Dix, I'm not good at multiplying fractions. How am I supposed to do that? How are you supposed to multiply fractions if you're not good at it? Use Desmos. Just type in 3 times 1/2 and it'll tell you 3/2. And z to the 5th times 1/2. What's 5 times 1/2? 5/2. So that would be z to the 5/2 power. And that would be down there in the exponent. I mean, in the answer choices, not in the exponent, in the answer choices. So what you have to remember is that the exponent goes in the numerator of the fraction, the root goes in the denominator of the fraction, and the square root of y squared is actually just y, because 2 times 1/2 is 1. What would this look like if I individually changed it to radicals? So this is the answer we want, but I want to show you what it would look like if I changed it to radicals. It would be the square root of x to the 3rd times y over the square root of z to the 5th. But then I wouldn't be able to leave square roots in the denominator, and I would have to multiply to get it out, and we're not dealing with all that right now, so we're just going to leave it how it is. This one that I boxed is what it wants for the answer. Yes, ma'am. Do you have a question? You need me to zoom in? Anybody else have a question? All right. Notice the next part has a paragraph. And it is because I have mentioned this like 3 times this year, but I've never had you write anything down about it. So I wanted to make sure you had something written down about it. Now, this is also something that's going to be on SC Ready. So you need this for both tests, SC Ready and EOC. So it's very important you know the difference between a rational number and an irrational number for this test coming up. Actually, for 3 tests coming up. So I've written it down. We're going to underline some key things, make sure you're good there, answer questions, and then we're going to start the actual question. It says rational numbers are numbers that can be written as fractions containing only integers. So if it can be written as a fraction, then it is a rational number. Well, how do we know if a decimal can be written as a fraction? There are 2 types of decimals that can be written as a fraction. The first one is a decimal that terminates. What does it mean to terminate something? Or to stop it. Like if I say your job is terminated, your job is stopped. You no longer have a job here, right? If I say your life is terminated, your life is stopped, right? So to terminate something is it stops, it ends. So a decimal that terminates means it stops. Or a decimal that repeats, like 0.3 repeating. Those are the 2 types of decimals that can be written as a fraction. So one that terminates would be like 0.5, 0.12. It stops. It doesn't go on and on forever. But a decimal that goes on forever without being a repeating decimal is irrational. So if something goes on and on forever, like pi. Have you heard in your lifetime that pi goes on and on forever, but it's not a repeating decimal? That's an irrational number. This is the biggie for your test coming up. If you take the square root of a number that is not a perfect square, it is always irrational. So the square root of a number that is not a perfect square is always irrational. So when you're looking at number 20 and it says, please tell if the sum is rational or irrational, you got to ask yourself, does it have a square root that is not a perfect square? Or it could have the letter pi in it. So looking at number 1, it says the square root of 9 plus 1/2. What's the square root of 9? 3. 3 plus 1/2 is 3 1/2. Can that be written as a fraction? So what type of number would this be? Rational. If you type that into Desmos, it would give you 3.5 as your answer, and is 3.5 a decimal that terminates? Yes, because it stops, so it's rational. If it gives you a decimal that goes on, and it eventually stops on there, but it's like 9 or 10 digits, that tells you it's irrational because the calculator can only hold that many digits. So what I want you to do is I want you to try numbers 20 and 21 and go through. You can use your brain, you can use Desmos, whatever you need, but I want you to tell me, is it rational or is it irrational for 20 and 21?